Okay, our lesson today is on domain and range and behavior and increasing and decreasing intervals. We learned about domain and range in the last lesson, but let's review it quickly today. So the domain of a function is the set of all allowable values on the independent variable. This is commonly known as the x values or inputs if you're putting them in the function machine. The range of a function is the set of output values. This is commonly known as the y values. Also, the range is when the domain is evaluated into the function and then you get an answer or you get an output. That's the range. So it's what comes out of that function machine if you were to use it. All right, so the domain is always going to be when you are looking for your leftmost and rightmost values on the graph. So you are literally looking from left to right on the graph. And where does the function fall? The range is when you're looking from top to bottom, from bottom to top. So if you're looking up and down on your graph, where is the function? You're looking for lowermost and uppermost y values. In the intro lesson, you learned about interval notation. We're going to be using interval notation to write our domain and range from a graph. Okay, domain and range always seems to be difficult for students, but if you just think about the basics and you maybe use a colored pencil or a highlighter on your graph and make it more of a visual problem, I think it'll be a little bit easier for you. So just a couple reminders, kind of going off the last lesson. If you have a closed dot, that's a solid dot. So a solid dot or a solid line is going to receive square brackets. If you have an open dot or if you have a dashed line, you're going to use parentheses. This is important to know. Okay, so for domain, I'm going to use the green highlighter for domain. So we want to know on the x-axis, where does this graph fall in between? So I'm literally just shading between the two endpoints. And then on my graph, I'm going to make a mark. This solid point is at the x value of -4. And this open point is at the x value of +5. So a solid dot receives a square bracket at the x value of -4, and an open dot receives a parenthesis at the x value of 5. Okay, I know that the graph goes up and down. It doesn't matter. We're literally, for the domain, looking at x values only. So those 2 points I marked in blue, and then it's in between where I shaded in green. Okay, I'm going to shade for the range in purple. So the graph on the y-axis falls between these purple or the purple shading. This solid point occurs at the y value of -4, while this open point occurs at the y value of +2. So -4 has a filled in dot, which is a square bracket. And at the value of +2, it's an open dot, so a round bracket. Remember that the smallest number always comes first. Okay, let's do the same thing on the next graph. For domain, let's shade wherever the graph is on the x-axis in green. Looks like it stops right there. Starts again right here. Goes on forever. Okay, so our domain appears to be on the x-axis from negative infinity to this point on the x-axis, and then starting again right here on the x-axis and going towards positive infinity. So our domain is negative infinity to -1 with a square bracket because it's a solid line in the coordinate plane, a union, another square bracket, +1 to positive infinity. Remember from the first video that negative and positive infinity always receive round brackets. All right, here's where it gets a little confusing for students to visualize. So for the range, if I'm going to highlight this in the purple, we want to know how high and how low does the graph go. Obviously there's a split in the middle here, but as far as the y-axis, so I'm just going to shade everywhere that there's a point. So everywhere that my purple line is touching that line that's graphed in the coordinate plane, and even though there's a break in the middle, everywhere that I just shaded, that line is actually touching the purple. So the graph has no restrictions. It's going up forever, and it's going down forever. There's no missing y values, meaning there's no actual break in the line anywhere on the y-axis. I know this looks visually kind of confusing because there's a break in the middle, but there is not a break as far as how high or how low it goes. So we're going to say the range is from negative infinity to positive infinity. Okay, end behavior. End behavior is exactly what it sounds like. So when you are using end behavior, you need to think of the end of the graph. Literally think of the end of the graph. Take a look at these examples for a second. These ones. I only gave you the ends of the graph. I didn't give you the middle of the graph at all. That's because we don't actually care about the middle. We only care about the ends for end behavior. So the degree and the leading coefficient of a polynomial combine to give another property called end behavior. The end behavior of a function describes the trend of the graph when we look to the right end of the x-axis and to the left end of the x-axis. So for the first set of end behavior, we're going to look at the two ends, which both head up. But to write the end behavior, you are going to start with as x heads towards positive infinity. And on the graph, x heading towards positive infinity is this way. So as you look in that direction, so as towards positive infinity, clearly the graph is heading up towards positive infinity. So we write f of x is also heading towards positive infinity. As x heads towards negative infinity, the graph is heading up, still towards positive infinity. So I'm just going to take a quick second and label all of my positive and negative infinities. Oops. Sorry. All right, so obviously we have our x value. We have positive infinity over here, negative infinity over here. But on the y-axis, positive infinity is towards the top of the graph. Negative infinity is if it's heading down. So just keep those in mind when you're looking at the other end behaviors so that you know which direction you're heading in. All right, number 2, or the second one, both ends of this graph face down. So as x heads towards positive infinity, the graph is heading down towards negative infinity. And as x heads towards negative infinity, the graph is still heading down towards negative infinity. The third example, as x heads towards positive infinity, the graph is heading up towards positive infinity. And as x heads towards negative infinity, the graph is heading down towards negative infinity. And lastly, we have the ends of this graph here. Oops, sorry about that. As you head towards positive infinity, the graph is heading down towards negative infinity. And as you head towards negative infinity, the graph is heading up towards positive infinity. These are the 4 cases. So end behavior has to be one of those 4 that we just marked. For the first example, take a look at the ends of this graph. Also, we start by looking towards positive infinity on the x-axis. As we look towards positive infinity, is the graph heading up or is it heading down? You have 2 options. And I would say this graph is heading up. So if it's heading up, it's heading towards positive infinity. Looking at this end, as we head towards negative infinity, is the graph heading up or down? And it's heading down towards negative infinity. So we would say as x heads towards negative infinity, the graph heads towards negative infinity. Number 2, we have 2 ends of the graph. As x heads towards positive, the graph is heading up towards positive infinity. And as x heads towards negative infinity, the graph is still heading up towards positive infinity. Last example, our 2 ends. As x heads towards positive infinity, this graph is actually heading down towards negative infinity. And as x approaches negative infinity, this graph is heading up towards positive infinity. So if you haven't noticed, this first part never changes. So I always write them in the same order. The second part is what changes based on the graph. So we always start with as x approaches positive infinity, and then we end with as x approaches negative infinity. Okay, complete the on your own section by yourself. Answers are on my website. And lastly, let's take a look at increasing and decreasing intervals. So I just typed up this quick graphic and I used an ant. You can think of anything, I just had the graphics for an ant. So I said, think of an ant climbing on a graph. For this rule of increasing and decreasing, know that the ant can only crawl from left to right, kind of like how you would read a book. You would read from left to right. If the ant is climbing uphill, then the graph is increasing. If the ant is climbing downhill, then the graph is decreasing. And if the ant is climbing on flat ground, the graph is constant. But remember, of those 3 rules, you have to recall that you're reading from left to right. That's how the ant would walk. If we look at this first graph, we drop the ant in on this graph over here on the left. It would walk uphill till it got to that point, and then it would turn and it would be walking downhill. So when you're writing increasing and decreasing intervals, the biggest thing to remember is that you write your increasing and decreasing with x values only. And that's going to get a little bit confusing because the graph is actually going up or down on the y-axis, but you're using your x-axis to write the increasing and decreasing intervals. Also, we need to write these in interval notation. All right, looking at the first graph. So if we're looking at x values only, that means we need to take the x value of this coordinate, which is at -1. I always label my graph because we start on the left, meaning we start at -infinity, and we end on the right, meaning we end at +infinity. These two values always exist. So if we start on the left at -infinity, this graph is increasing from -infinity until this point, which is an x value of -1. And you always use parentheses with increasing or decreasing intervals. You never use square brackets because at this point, we wouldn't be able to determine if it was increasing or decreasing. It's called a turning point, so we do not include it. So to add to our list of important things, you always use parentheses. Never use square brackets. All right, continuing on this graph. So we're currently stopped at this point right here, where the graph changes direction and starts to head back down. So that graph changes direction at an x coordinate of -1 and heads towards +infinity. Again, do not be confused. We're talking about x values. So we start at -infinity and we're moving all the way towards +infinity. And while we're doing that, we're looking to see if the graph is heading up or down, which it is. Heads up until -1, and then from -1 to +infinity, it heads down. In this example, there are no constant intervals. Number 2. So for number 2, the graph is heading up here, and then it's heading down, back up, down, constant, back up. We're looking at x values only, so we start at -infinity, we head all the way to +infinity. We have a lot of intervals happening in this graph, so you're going to have to use unions when you're listing them. And I like to just keep a running list going, so I start on the left and I just keep adding wherever I need to. So starting on the left, starting at -infinity, it looks like we have, starting at -infinity, we go up until the x coordinate of -4. So we're increasing from -infinity to -4. At -4, we head down all the way to this point, which has an x coordinate of -1.5. So we are decreasing from -4 to -1.5. At -1.5, we start to head back up, and we're heading up until this point here at x coordinate 0. So I'm going to go back up to increasing, put a union. We are increasing from -1.5 to 0. At 0, we start to head back down until this point, which is at an x coordinate of 1. So we are decreasing from 0 to 1. At x coordinate of 1, we are staying constant until x coordinate of 4. So between 1 and 4, we are constant. And then at 4, heading towards +infinity, we are going back up. So that's our last increasing interval. Whenever you have multiple intervals, you need to make sure you're using a union to separate them. All right, for this last section, I'm gonna do the first one with you, and then the second one you can do on your own, and you can check it on my website. All right, this is all 3 parts of what we've done on this note sheet, and all 3 parts have separate directions, so you are going to have to reference back to the directions. For part A, we're looking for the domain and range. The domain is x values. So I'm looking how far left or how far right does this graph go? It doesn't appear that this graph ever stops. It looks like it continues to get wider and wider forever. The domain is negative to positive infinity. The range, however, looks like the graph starts right here. That would be at -4 on the y-axis, and then it heads up forever. And the range is y values. So I would write this with a square bracket because it's a solid line in the coordinate plane at -4, and it heads towards positive infinity. End behavior is the actual end of the graph. So as x heads towards positive infinity, the graph heads up, so it is also heading towards positive infinity. And as x heads towards negative infinity, the graph is still heading up towards positive infinity. Increasing and decreasing intervals. Increasing and decreasing intervals always use x values and start on the left of the graph, looking towards the right of the graph. It appears that this graph on the left starts to head down, and then at this point, which corresponds to an x value of 1, it starts to head up. So we're starting with a decreasing interval from negative infinity to positive 1. At 1, the graph turns around and heads back up. So from 1 to positive infinity, the graph is increasing. Okay, check the last example on my website. The note sheet will be posted. And let me know if you have any questions.